For the last video of section 6.4, logarithmic functions, our objective is going to be to solve these log functions. And then I also want to talk about a couple different kind of common or special log functions and just how to solve those as well. First, I want us to recall kind of the theorem that we had, the definition of log functions. So we have that, y equals log base a of x if and only if, x equals a to the y. So we have log form and then we have exponential form. Our first common logarithmic function is what happens when our base, or our a, equals 10. So rather than writing y equals log 10 of x, mathematicians would rather just write it as y equals log of x. So when it says log of x and there's no little number, there's no base, we assume that the base is 10. And remember, this in exponential form is going to be x equals 10 to the y. Our next special log function is when we have our base a is the constant e. So, rather than writing y equals log base e of x, we write this as y equals ln of x, or the natural log of x. So we know kind of y equals ln of x based on our theorem. This is if and only if, so in exponential form, x equals e to the y. Now, when we graph this in the graphing calculator, it's similar to how we would graph, our log function. There is a button, it is underneath the log button, and it is an ln button. So if you were typing in your y equals, you would type in that ln button and then x, and that's how you would graph it in your calculator. Okay, now we want to solve log equations. Our first example here, we're going to solve log base 3 of the quantity 4x minus 7 equals 2. And our first step when we do this is going to be to change to exponential form. And you'll notice, I wrote those off to the side, like I've already talked about. I like to write those on my paper kind of right away. So let's rearrange this. So let's see, the x piece is kind of this piece right here, that 4x, so 4x minus 7 equals, and then it's our base a to the y. So our base in this case is 3, so 3 to the y, which is 2. Now, we have a normal equation that we know how to solve. We're going to simplify and solve this. So 4x minus 7 equals 3 squared, which is 9. Add your 7, add your 7. So we've got that 4x equals 16 divided by 4, x equals 4. Our next example of solving log equations, we have the function log x of 64 equals 2. So remember, first thing, change it to exponential form. So let's see, the 64 is going to be that x there. So 64 equals our base, which is x, to our exponent, which is going to be 2. So 64 equals x squared. Now we're going to simplify and solve this. Well, we know how to solve this guy. We take the square root of both sides. So the square root of 64 is going to be plus or minus 8. So x equals plus or minus 8. All right, example 9, we're using logs to solve exponential equations. These ones are fun. So for letter A, we have e raised to the 2x equals 5. And I put kind of our definition on the side of y equals natural log of x, and then x equals e to the y. It's important to note that natural log and then e are inverses of each other. So to solve this equation, what we're allowed to do is basically take the natural log of both sides. Because from here, the natural log of e, that cancels and our 2x comes down. So this equals then, 2x equals the natural log of 5. trying to get the x by itself, we got to divide by 2 on both sides. Divide by 2. So x equals the natural log of 5 over 2. There are some on your homework where you have to leave it in exact form like this rather than do the decimal.